Okay, for this paper, we'll be doing year 2018. So some general comments that maybe you should take note of. Use of mathematical techniques was a considerable strength for candidates. That means students are better at calculations, right? So better performing candidates will explain clearly the steps in the calculation. So not just arriving at the final answer. They'll show their workings, they'll show the formula. Where calculation involve use of multiples of sub-multiples of units, that means prefixes, okay? They have difficulty in converting. So please go and memorize your prefixes and the use of standard form, okay? You don't need to express your answer in standard form, but you must know what to key in into your calculator when they give you the values in standard form. Okay, so better performing candidates express their ideas clearly and concisely. That means they don't write over. Then others simply wrote down all they knew about a topic. Okay, so basically they just talk about the topic. Now, weaker responses simply restated the question or candidates answered their own question rather than the one that's asked. That's quite common. You all just talk about what you want. Okay, then there are many candidates who ignore instructions as to where and how questions should be answered. They did not follow instructions, make things difficult for themselves and lost time needlessly. Okay, let's go into the question now. Question 1, solar panel uses energy from the sun to charge a battery as shown in figure 1.1. So this is the solar panel. Complete the following sentences to describe the energy transfers that take place. Okay, so the solar panel transfers the energy from the panel to the battery as electrical energy. Yeah, but we still need to know some idea lah. So, firstly, you must recognize that it's electrical energy. But then if it comes out, then you must write in the, but there's no electrical store, right? Chemical potential store, right? Okay, so in the battery, it actually stores the energy as chemical potential energy. So they will sort of rephrase it lah, right? So they will actually store the energy as energy in the chemical potential store. Okay, so total energy transferred to the battery is less than the total energy incident on the solar panel because part of the energy incident on the solar panel is transferred, okay, to thermal or energy in the internal store. Okay, so part of the energy is also lost due to reflection of light. So this is the comments. Many candidates realize that energy is transferred to battery as electrical energy. So take note, if you are talking about chemical energy, there's no such thing. It's always a store. So we have 3 stores. What are the 3 stores? Chemical, gravitational, elastic. Okay, so these are those with the potential, elastic. Okay, then those without potential will be kinetic. What else? Kinetic, what else? Okay, so these are the different chemical stores that's in our syllabus, and on top of that, you need to know about the 4 pathways. Okay, I'll leave it to you to go and find out. Okay, now question 2 is not in our syllabus. You don't need to know how to draw. Okay, question 3, it shows a distance time graph. So when you see distance time graph, what comes to your mind? Represents speed or velocity, yeah? Then if you have ruler, you can always use it to put against the line to see whether is it constant gradient or not. Okay, but do take note there is a trap here. The units is listed as km. Okay, how about the time? Time is in minutes. So later on, if you want to do it in meter per second, you have to do your own conversion. But let's see. Okay, the train passes without stopping through stations A, B, C, D, E, and F as shown in figure 3.1. Using figure 3.1, determine the distance between stations B and E. This is a very simple question. But if you don't read it, you go from A to F, your answer is wrong. Do I have anyone that made this mistake? That means never read. You see, that's how O-level do. They list down everything, but if you're not careful, okay, you will miss out this. So from the graph, the distance between B and E is 65 km. That means you just take the distance between B and then E, then you subtract. Now, state between which two stations the train has its lowest average speed. So the gradient is representing speed, right? So as long as you find the least steep gradient, which is between B and C. So how do I determine? I can actually use a ruler, right, to put against the line and see where we have the least steep gradient, and that will be our answer. After that, calculate average speed. Average speed must be total distance over total time. They say in km per hour. So anyone didn't change it to hours, then you will have gotten your answer wrong. So it will be 107 km per hour. Please mark and give yourself the marks. Okay. So question 3, the comments is large majority gave the correct answer, so it was too simple. Most common mistake resulting in unrealistic distance was to find the area under various parts. Why do you think they find the area? Because they thought it is a speed time graph. So when you're given kinematics graph, always look at the axis, know the units. So if it's distance time, it will be gradient representing speed. If it's speed time graph, gradient will represent acceleration. Area under the graph is the distance traveled. Okay, B and C were usually identified. So there are sometimes people who give the wrong ones. So maybe they read wrongly. Okay, better performing candidates determine the distance and time properly. Okay, so I think this one is okay. So question 3, you should be getting full marks. Now question 4, I don't know whether it will be really tested like that or they'll give you some help. Okay, but I'm just going to go through in case this being the first year, they do something weird. So there are 4 rays that are drawn there. But out of these 4, there are only 3 that we know that can actually help us determine where the image is. There are 3. We can really predict how they will move. What is their, how they will travel. Okay, these are the 3. The first one is this. Notice that this is actually parallel. You need to know this term. This is parallel to the principal axis. Okay, this is parallel to principal axis. And once it touches the lens, which is L here, it will cut the principal axis at the focal point. So this is the first light ray that of all the millions of light rays that comes out from the object, this is one of the 3 that will tell me, or rather I will know how they will behave. They are very predictable. Okay, so as long as they are parallel to principal axis, once they touches the lens, they'll move on to cut the principal, they'll go and cut the focal point, capital letter F. Okay, by the way, from the lens to your capital letter F, this is what we call focal length. Okay, so this is your focal length. Sorry, shifted. So this is actually your focal length. You can measure. You can measure. Now you see, the object is placed 25 cm. 25 cm. And because they use all these grid lines to help us to measure. So if this is 25 cm, from here to lens, we have how many big squares? 2.5 big squares. That means every half big square represents 5 cm. Correct? So we can actually measure what is the length of focal length. So it must be from focal point to the center of the lens, which is called the optical center. Then we also have another light ray that we can predict very precisely every time it is drawn. It is the light ray that passes through the optical center. the light ray that passes through the optical center will never bend. So with these two light rays, I can actually determine that the image should be here. So in this question, instead of asking us to draw, they give us the position of the image. And if you know the characteristics of all these light rays, right, out of the three light rays that is predictable, we should be able to draw a corresponding point to the tip of the image. Okay, and I say this again, if the image is found on the right hand side, it must be inverted and real, right, like your infrared. If it's found here, it must be upright and virtual. Okay, so let's see what the question wants. The diagram is drawn to a scale where 1 cm represents 5 cm. That means if you are doing it on regular A4 paper, every 1 cm on the paper would represent actual 5 cm. Why we need that? Because later for our magnification. So in this case, they tell us where the image is. And indeed, it is inverted and real. They tell us inverted. So once they tell us that it's inverted, it must then be real already. Okay? Then state one other property. So it is either inverted real, magnified or diminished, or upright virtual, magnified or diminished. If it's inverted, it must come with real. If it's upright, it must come with virtual. But the magnified, the diminished, bigger or smaller, will depend on how it looks like. Okay? So once you write that, again, your 1 mark, complete the 4 rays from the top. So I have shown actually 2 rays, the predictable one. How about the other 2? They must also converge at the image. Cannot be, I see an image of something and it is formed just by 3 light rays. Millions of light rays actually converge. Okay, so with that, I can then draw out these 2. I'm actually unable to predict, okay, if the image not given. But since image given, I can actually predict where they will end up, right? Then they say determine the focal length. So this is what I did. Okay, my focal point is here. Then my focal length I can actually measure. And because it is drawn to scale, I have 3 cm between the center of the lens and the focal point. So 3 times 5, you must give focal length of 15 cm. Okay. Now magnification is image distance over object distance. So again, you do a measurement. So you will get magnification of 1.5. So just like that, you get 3 marks, which you don't really get nowadays. Okay. Okay. Yeah, I think this thing you can just read it by yourself. It will be in the video. Okay. Okay. Can we go to question 5? So we have 5 different musical instruments A to E produce sound waves in air. So the medium is air, right? The excess pressure of the sound wave above normal atmospheric pressure is measured. So this is the normal. Okay, anything that is above it will be shown on the top part. Anything that is less than the normal will be shown at the bottom part of the y-axis. Okay, sorry, x-axis. Now, variation for each instrument is shown. Okay, so what do you notice? What kind of graph is this? DD or DT? Or PD or PT? PT, right, is pressure versus time, right? So what can we get from the y-axis? The amount of pressure, correct? What can we get from the x-axis then? We can get time, which is then also period, right? What is period? Time taken to complete one wave. Okay, so at first glance, which one has the largest period? A, B, C, D, or E? E has the largest period, right? That means which one has the lowest frequency? E has lowest frequency because of the formula period equals to 1 over f. The larger the period, the lower the frequency. Okay? So this is looking at the graph even before we look at the question. Determine the frequency of the sound waves produced by instrument A. So you need to make sure you read and go to A, and they want the frequency. So let's do this together. Can you tell me when is one complete wave? We start from here, we go up. Tell me when to stop. Stop, okay? So it actually goes back to the original position, right? So then you read from time 0, time t equals to 0 to time t equals to 4. That is the time taken to complete a wave. Therefore, period will then be 4 seconds. Simple? Okay, so answer is 4 seconds for the period, but they are looking for the frequency. Then frequency is 1 over period. So I'm actually wrong because I didn't take note that it is in milliseconds. So it is not 4 seconds, it is 4 milliseconds. Right? So this must be converted to SI unit of seconds. So we take 4 milli as a value of 10 to the power minus 3. So with that, you should get 250 hertz. Okay? So this question is actually quite demanding because you need to first be able to determine the period. You need to be able to know the milli, and you need to know the formula. And they only give 1 mark. Okay, so this one is quite, maybe it's to test the better students. The better students will be able to. Now write down the letters of all the musical instruments that make a sound that is louder. So loudness is determined from amplitude, right? And from the amplitude, if I have larger pressure, I should have larger amplitude, right? So the answer is B and E. Let's take a look. It must be louder than A. So everything measured with respect to A. A has an amplitude of 0.1. Okay, amplitude is always from the rest to the crest. Crest being the highest point. So this is the crest, and the lowest point is actually called the trough. So anything that is more than that, which is B, C no, D no, and E yes. Okay, so answer will be B and E. Now lower pitch than that from instrument A. So lower pitch means lower frequency. If I have lower frequency, it means my period must be larger, right now. You can only get period from the PT graph or DT graph. You cannot get it directly. You need to do a 1 over to get your frequency. You cannot get frequency, but you can see how many waves are completed. That sort of gives you an idea as well. Okay, so will be C and E. Why C? Okay, so it is with respect to A. So for A, and you see that the time frame is 0 to 7 seconds, right? How many waves did A complete? 2. Less than 2, right? Less than 2. How about C? Okay, so actually C actually starts somewhere here, right? You see the crest of this. So this is actually like 1 wave, right? And it doesn't even complete a quarter of a wave. Whereas for A, it actually completed 1 wave, and it is close to completing the second wave, right? So actually, A has a higher frequency, but they are looking for lower frequency wave. So it will be C. Yes, Karen? Third, to give the correct number of vibration in 1 second. So actually, if you miss out the millisecond on the x-axis, you will have made the mistake, you will have lost 1 mark. Okay? Okay, next, this is a red light. It has a wavelength. So wavelength, do you still remember what is the symbol to represent it? Your lambda. Okay, and what is the formula associated with lambda? V equals to F lambda. So even before I read what is required for me to answer the question, right, I must have all this background information ready. Meaning if they tell you wavelength, you straight away think of this, and you straight away think of this formula. It must be a very automatic response. Okay? Now the speed is then this. What is the trick here? Km per second, no? If you are not careful, then you will just use it as km per second, right? But this is a SI unit formula. That means everything must be in SI unit, which means my V must be in meter per second, frequency must be in hertz, and my wavelength must be in meters. So far my wavelength is in meters, it's okay, but my speed, so this is a trick here, right? And if you don't take note of all this, you will get 0 marks. You will get 0. Even though you know the formula, you have done this countless of times, but you didn't pay attention to the units, you will have gotten 0. Now, state one region of the EM spectrum in which the radiation has a frequency lower than that of red light. So this is seldom asked, but let's go through the sequence again. Ronald, I will not put it on video. Okay? So this I is actually called infrared. Infra means less than red. Okay, something that's less than red. So visible, you know the sequence is Roy give birth in Vietnam. Okay. You mean you all don't know? Roy give birth in Vietnam. So it's no surprise that infrared is before red. What is less than red? Infrared, no? Then the other end of the color spectrum, we end off with violet. What is after violet? Ultraviolet. Ultra means more than, right? Ultra means more than. Like I wear Ultra Boost for Adidas. So it is more than the boost. I get Ultra Boost. Okay? Ultraman also more than man. So you need to know this sequence and you need to know the colors because they say has a frequency lower than that of red light. That means it must be gamma actually has highest frequency. Radio actually has low frequency. Okay, so you should be writing this down and not be just thinking through in your head, in your mind. Even for me, I also need to write this down to make sure I don't even make this mistake. And I'm saying writing this down when you're doing the exam. When you're doing the exam, you must write this down. Okay? So you don't store too many things in your head. Then, if I'm looking at a frequency that's lower than red light, that means I'm looking at infrared, I'm looking at microwaves, I'm looking at radio waves. Why? Because if I move to the left, the frequency decreases. Then they say, state a use for the radiation that you have named. So please be careful. If you are writing down infrared on the region on top, then your application must be the one that is using infrared. Okay, it cannot be you put infrared, then after that you say, oh, microwave oven. Okay, like if over here your answer is infrared, right? But your answer here is microwave oven. Infrared is not even used in microwave oven, so it must be the same application. Okay. Huh? You need both to get the marks. You cannot write infrared and instead of writing the correct application, you can write radio. You can't. You get 1 mark for the top one. Okay? It just doesn't make sense. Wait, you see here, it has a lower frequency, suggested an appropriate use of the radiation. So the application must be appropriate. Cannot be, I talk about infrared, but the use is microwave oven. Okay? Yes, you need microwave oven. Yes. What cooking? No. Refer to the ones in your notes. Okay, so Okay, as you can see from here, the answer that they provide is 4.2 times 10 to the power 14. How many SF is this? 2 SF, 4.2 is 2 SF. So it can either be 2 or 3 SF. So 4.17 is accepted also. Alright, 2 or 3 SF. Okay, now this is a hot water tank. If you see a hot water tank, what comes to your mind? Which chapter is it? Conduction, convection, or radiation, thermal energy transfer. So we have an immersion heater that is at the bottom. For health reason, the water must be kept at a temperature above 65. There's a sensor attached to keep the temperature above 65. If water temperature falls to 65 or below, it will switch on so that the water is heated. Now, outer cover of the immersion heater is made of copper. Copper, what do you think of? Metal, what do you think of? Conduction, right? So later we'll see if it appears in the question, right? And if we see water, water is actually a fluid. So if it's a fluid, it means there is a chance of convection. And they can also ask you questions pertaining to conduction because fluid, like water, is a poor conductor. Okay, so you must be very aware. But actually, if you keep doing the 10-year series, you'll find that the questions are quite repeatable. They cannot come up with new application. It's either water heater or aircon or bag of ice. Okay, it's actually very predictable. So please read my notes. Now, describe the process by which all the water in the tank is heated by the immersion heater. So this must be our convection. Okay, so if you remember my template is VDACC, V is volume, D is density, action, then you compare. In this case, you are heating the water. So a simple word, simple sentence to compare that the cooler water sinks, cooler denser water sink will suffice. And then lastly, you follow up with formation of convection current. Please mark your own work. Then you might want to bring in this. What is the reason why convection happens? It's actually because of difference in density. That's why you can always say the difference in density sets up a convection current. Okay? Now, the temperature sensor may be placed on the wall of the tank either at point X or at Y. State why point X would be the better position. Okay, let's take a look. What is the purpose of the sensor? To take note that the temperature do not fall below 65. Okay? So X and Y. Why do you think X would be a better position? Due to temperature difference, the upper parts of the tank contain water that's hotter than the lower part. Right? What is the purpose of the sensor? Placing the temperature sensor at point X allows water above point X to be maintained above 65. Let's look at the Marcus report for this. This is the most challenging question. Majority suggested such things as X being nearer the heater or the cold water inlet without pointing out why this may be beneficial. So basically it is beneficial. But why? Others simply suggested that it will be more accurate at X. A significant minority related this question to another they come across. So did not answer the question. So do you all understand this? Why the point X will be the better position? Okay, Can Because I want the water in the tank to be minimally 65 degrees. Okay, so if I put it at X, once the temperature falls below 65, I will activate my heater. Okay, and that will make the minimum value of the water in the tank to be at 65. Okay, electric fields we covered yesterday. So they just want us to draw arrows. Okay, so how did they come up with a pattern like that? Right? The lines cannot cut each other. The lines cannot cut each other. So basically, if I have two positive charges, and let's say this one by right it should go this way, right? So if I were to draw out, then they will have cut each other. They will have violated the rule that the lines cannot cut each other. So that's why they curve out. They curve. Okay. Then now to see whether you understood the other day, why is the direction away or coming up from the positive charge? How did they come out with this direction of the charge? Direction of this field? They were using a small positive test charge. So if I have a positive, the force on this will be away from it. Okay? So the field lines are directed away from positive charge. Okay, a girl touches a door handle, the charge flows from her hand to her, resulting in her feeling an electric shock. There's an average current. So what letter? I. So if you have gotten the answer correct, then it's fine. But if you have not, then I suggest that you underline and annotate what all these numbers mean. So this will be T. Show that the charge is what letter? Q. You need to know. But the units is coulombs. So then you can relate to the formula Q equals to IT. Of course, before your exam, you will memorize all the formula. But even though you memorize a formula, if you are not able to identify what those numbers means, there's no use in memorizing. Okay, so you always need to know what is their formula. So if I use Q equals IT, I should get this answer. But you take note, there is milli. Just now at the start of this video, I already show you the Marcus report to say that some students were not able to handle the conversion of the prefixes. Okay, so just to make sure that you all know, 4.2 megawatts. How do you convert it to watts? 4.2 megawatts. How do you convert it to watts? So firstly, you need to know that this is a prefix, and this prefix is called mega. Okay, and then what is the value of mega? 10 to the power of 6. Right? Now, to convert from prefix to no prefix, what do I need to do? Multiply by value of prefix. So this is the rule that you always follow and you won't make mistake. Whether is it milli, which is 10 to the power minus 3, nano, 10 to the power minus 9, as long as it's from prefix to no prefix, you multiply. What if it's from prefix, no prefix to prefix? Then you divide by the value of the prefix. Okay? But first of all, you need to memorize all the values of the prefix. Okay, then the average potential difference between her hand and the door handle during the electric shock is 150,000 volts. Okay, so this is the potential difference. So this is my V. Calculate the electrical energy. So this is my E that is transferred during the shock. It is a continuation of the above question. Part 1, part 2. So what is the value that I need from part 1 is actually the charge. So we have this formula V equals to W over Q, right? Given V, given we are supposed to find the electrical energy, and this is from part 1. Then we can get 0.27 joules. Okay? Now, every time the energy is expressed in joules, everything must be in SI unit because joules is an SI unit. Are we okay? Can 2 or 3 is okay. Okay, this anti-freeze to prevent ice forming on aircraft wings. Substance must be a liquid between -50 and 120. Cooling curve. So this is our the kinetic model, right? So why is it that there are flat areas and what do the slopes represent? Slope means temperature changes. Flat means change state. Okay, so we have three substances X, Y, and Z. And our requirement must be a liquid between -50 and 120. So which of these suits? It is a liquid at 120. So this one you just read. Did they start off with solid, liquid, or gas? Did they start off with solid, liquid, or gas? You see, there are one stage. So this is simple. It must start with gas. It must start with gas. But if I just give you a graph that looks like this, over here, is it gas or liquid? No, you don't even see the temperature. How do I know whether this is gas or liquid? Can it be solid? No, right? Because after solid, then there's a change of state. Change to what? Don't know. So can it be gas or liquid? It can either be gas or liquid. It depends on the question. It depends on the question. But what if I give you a graph that looks like this? Then it's for certain, I can be very sure it must be gas. It cannot be liquid over here. Cannot be. Because after liquid, it changes state, then here becomes solid, right? Then after that, change to what state? So in fact, which one is the most complex? The more difficult one that will make students make mistake. It is this. Students don't read carefully. They assume that this must be gas or assume that here must be liquid. Then if the question is suggesting otherwise, wrong answer. But if it's something like this, it must be starting with gas. Okay? So this is very simple question. State which substance are liquid at 120 and -50. You can just read off from it. The key concept here is flat. Flat means change state. Slope means change temperature. Motorcycle and rider have a combined mass of 530. Combined mass, so what letter? M. Motorcycle accelerates from rest. Rest is U equals 0 to 26 meter per second in 3.25 seconds. It's always good to make sure that you check the units, right? So what is the accelerating force? So you first need to calculate your acceleration. So it's 8 meter per second square. Whenever there's acceleration, there's going to be F net, and that will be our accelerating force or our net force. So did you get 4240? Okay. Now the distance traveled in 3.25. This is tough. I'm sure they will mention this in later on in our the Marcus report. So what would some people do? Distance equals to speed times time. They will do this. They will use speed of 26. There, I got speed, I have time, They will get this. And this is wrong. Why? I've told you many times. It doesn't travel with 26 meter per second throughout this 3.25. The work done by the accelerating force, then you need to use the distance. So guys or girls, even though your distance calculation may be wrong up there, they will still give you 1 mark error carry forward. Okay, so check. So like let's say Yuki didn't get this correct because she always got it wrong. Then she continued down here with her wrong answer. She will still get 1 mark error carried forward. But let's look at part B. The candidates was evenly divided between those who multiply average speed by time and obtain the correct answer. Some go and find the average speed. Okay? And those who multiplied final speed by time and got an answer double than what it should be. Okay? Better performing candidates. Are you the better performing candidates? Did you sketch a speed time graph and found the area? So this is what they are looking out for. Actually, sometimes O level they will help you all. They will say sketch a speed time graph. Sketch a speed time graph, but they didn't. So some of the questions that we see in this year, they are there to differentiate the better performing ones than the average one. Okay?